Okay, so these are the notes for 3.6, which is about solving quadratic equations using the quadratic formula. So we have learned a couple ways to solve a quadratic equation. One way that we learned was if you have just an x squared term, or you've completed the square so you have parentheses squared, you can use the square root property. And the square root property said that if you square root both sides to kill a squared, you have to tack on plus or minus. We also learned about quadratic equations and setting them equal to 0 and using factoring. So you could have an ax squared plus bx plus c equals 0, and then you could use factoring. But what we've seen, especially when we were using the square root property, was that sometimes your answers are not necessarily rational numbers. Like, they might still have a square root in them, which means that sometimes your quadratic can't be factored using the tools that we've learned, right? The trig factoring, the AC method. So we want to talk about a way that's going to make it like that we're going to be able to solve any quadratic equation ever in the history of the world. And that is the quadratic formula. So the quadratic formula comes from completing the square. And it basically, like, if you complete the square using A's, B's, and C's instead of actual numbers, you will then have the formula for the quadratic formula, okay? So we could do this, right? Completing the square, just a reminder, completing the square, first you want to get x squared alone. So we have to divide everything by a. So I have x squared plus b over a times x plus c over a equals 0. And then you have to get your x stuff equals number stuff, which means I'm just going to subtract this c over a from both sides, because that's the only term that doesn't have an x in it. So I have x squared plus b over a x equals minus c over a. And then to complete the square, like, this is all set up. This blue and red step are set up, but now we're going to actually complete the square. So when you complete the square, you take the coefficient of x, and we're going to times it by 1/2. And then once we get that number, then we're going to square that number. So if I take b over a and I times it by 1/2, that gives me b over 2a. And then when I square that, right, b over 2a times b over 2a. I know when you square a number, you kind of just do it in your head, but here I want to show you the math. So that's b squared over 4a squared. Right? 2 times 2 is 4, a times a is a squared. So what do I need to add to both sides? I need to add b squared over 4a squared. And then this left-hand side becomes a perfect square. So this is actually a factorable perfect square. And remember, if you just know the first step of completing the square, that's what's going to go into your parentheses. So I'm going to write this as x plus b over 2a squared equals, and then on this right hand side, trying to see if I have a different highlighter here, on this right hand side, we're just going to write those next to each other. B squared over 4ac minus c, oh sorry, ac, sorry about that, 4a squared minus c over a. And if we wanted to put those two guys together before we did anything, we would need to get another 4, or a 4 and an a down here. So we'll times this top by 4a. So my right-hand side becomes b squared over 4a squared minus 4ac over 4a squared. So my equation has become x plus b over 2a squared equals b squared minus 4ac over 4a squared. So now that we've completed the square, and again, normally in completing the square, these are all numbers, but we're doing it with a's and b's and c's, so you can see where the quadratic formula comes from. So now we've completed the square, we're going to square root both sides. But remember, when you square root, it kills the square, but you're going to have to do it to both sides, and you're going to have to tack on plus minus. So on the left-hand side, you have x plus b over 2a, and on the right-hand side, you have plus or minus the square root of b squared minus 4ac, and underneath, you technically have the square root of 4a squared. But if you look back to this green step here, the place 4a squared came from was squaring 2a. So we can actually simplify that just a tiny bit more. b over 2a. And I would say plus or minus the square root of b squared minus 4ac. Big divides, and now the square root of 4 is 2, and the square root of a squared is a. And then the last thing we're going to do is get x alone by subtracting b over 2a on both sides. And you see how those are the same bottom. We have minus b over 2a, and then plus or minus that square root over 2a. So we can put those together and we get x equals, so these cancel, and I have minus b plus or minus square root b squared minus 4ac, and then that whole thing was over 2a. And this is the formula for the quadratic formula. So the quadratic formula says, quadratic, sorry about that. The quadratic formula says, if you've got this set up, so I'm going to zoom out so you can see where we started. We started with, draw. Let me just get a different highlighter. We started here with ax squared plus bx plus c, and we landed at x equals negative b plus or minus the square root of b squared minus 4ac, whole thing over 2a. So the quadratic formula says that if you've got the right setup, you can use this formula to find x. All right, so now let's practice. The first thing we need is the right setup. So first we need to make sure it's set up properly. So that's ax squared plus bx plus c equals 0. So specifically 0 on the one side, and on the other side you want descending powers like a normal quadratic polynomial. So I need to set this up properly just by subtracting 8. So I have x squared plus 3x minus 8 equals 0. So now I've set up properly. That's cool. Let's write it down. So now if the best way to remember a formula is to just keep writing it so you can keep using it, and eventually you won't have to copy it down, you'll have to remember it. Okay? So here the coefficients A, B, and C. Now I know that for A I didn't highlight anything, but remember there's an understood 1 there. So our coefficients are A equals 1, B equals 3, and C equals -8. We're going to use the quadratic formula, which says x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So the first thing we're going to do is just straight replacement. Everywhere we see a, we replace with 1. Everywhere we see b, we replace with 3. Everywhere we see c, we replace with -8. I'm not going to do any math. I'm just going to do straight replacement. And as you're learning how to do this, start with just replacing. Try not to do any math in your head because you could mess something up and you don't want that. Okay, so let's substitute. X equals the opposite of b. So b was 3 plus or minus the square root of b squared. So b was 3, so 3 squared minus 4 times a, which was 1, times c, which was -8, all over 2 times a, which is 1. Now, if I was standing in front of you right now, I would say, what part looks the hardest? And most of the time, everybody says this part. Like, there's a lot going on under that square root. Like, there's a lot of math. So one trick is to kind of come over outside and do that math. 3 squared minus 4 times 1 times -8. So 3 squared is 9. And then -4 times 1 is -4, so -4. And now I want to times that by -8, so 9. And then -4 times -8 is +32. So 9 plus 32 becomes 41. So this number under the square root, which is, it has a fancy name, it's called discriminant, is 41. So I'm going to come back and I'm going to do the other math, right? There was a little bit of math here, this math and this math. So I'm going to do the blue math and I'm going to replace the number under the radical with 41. So I have x equals, now negative times 3 is just -3, plus or minus the square root of 41, big divides, and then 2 times 1 is 2. So first, you set it up properly. Second, you use the formula, which is what we just did. And third, you're going to simplify, if possible. Not everything gets simplified. So when you're simplifying, the first thing you're going to do is try to simplify the radical. If you can simplify your radical, then you're going to try to simplify the fraction. So if the radical simplifies, then second, you're going to try to simplify the actual fraction. The whole thing If the radical doesn't simplify, then you just stop and you've got your answer. So you're only trying to simplify a fraction if your radical simplifies into something else. So to simplify a radical, we're going to break it into prime factors. It turns out 41 is prime, so the square root of 41 does not factor, and this is my final answer. And remember, you can write that as two answers, right? X equals -3 plus the square root of 41. Big divides 2, and then -3 minus the square root of 41, big divides 2. So writing it either way is fine. Let's try it again. So in number 3, I've actually already got it is set up properly. So set up, check. Now let's use the formula. So the A value is 1, right, because this is technically 1y squared. The B value is 22, and the C value is -4. And we're going to use x equals -b plus or minus the square root of b squared minus 4ac, big divides 2a. So everywhere we see a, we replace with 1. Everywhere we see b, we replace with 22. And everywhere we see c, we replace with -4. So I have x equals -b, so negative times 22 plus or minus the square root of b squared, so 22 squared, minus 4 times a times c. So a was 1 and c was -4, all over 2a. All right, again, hardest part is this radical. So I'm going to have to do that math. I have to do 22 squared minus 4 times 1 times -4. Now 22 squared, not something we know in our heads. We're going to take out our calculator. We're going to do 22 times 22, which makes 484. So I have 484. And now -4 times 1 is a -4, times another -4 makes +16. So 484 plus 16 is 500. Oh, cool. So I'm going to do the other little math. The negative times 22 and the 2 times 1 while I replace my radical. So I have -22 plus or minus the square root of 500 all over 2. The square root's kind of long here. Let me erase some of it. Okay, so if you got here, you've successfully used the quadratic formula, and now we just need to simplify. So the first thing we're going to try to simplify is the radical. So we need to take 500 and break it down. So I'm just going to write simplify radical. And 500, I think, is kind of clear. It's definitely 50 times 10. 50 is 10 times 5. And now we see this double 10. So we know a 10 is going to come outside. So I will rewrite that as 10 square root 5. So I have -22 plus or minus 10 square root 5 over 2. So we were able to simplify the radical. So now we have to see if we can simplify the fraction. So let's talk about that. When we simplify the fraction, we're going to look at the 3 numbers outside of the radical. So negative 22, 10, and 2. Now, first of all, you can't put the 10 and the 2 together, or you can't put the 10 and the 22 together, because the 10 is attached to a radical. You can't put the 2 together just with 22, because the 22 is attached to addition subtraction. So remember, those rules about radicals still stand. The easiest way to do this is to then decide if there's one single number which goes into all three of those values, the three green values, and those are all divisible by 2. So that's what I'm going to do to simplify my radical. I'm going to divide all of those non-radical numbers by 2. So, sorry, simplify the fraction. So let's see. Negative 22 divided by 2 is negative 11. Plus or minus. 10 divided by 2 is 5. Square root 5 stays. And then 2 divided by 2 is 1. Now, generally, we don't write the 1 on bottom. So this is a perfectly fine answer, or you can write this as negative 11 plus 5 rad 5, then negative 11 minus 5 rad 5. Either one of these are fine answers. Now, out of habit, I wrote x equals, but it was y, so we're just going to change this to y equals. Okay, let's try another one. 3x squared plus 1 equals 12x. So the first thing we need is to get it set up properly. And to set it up, I have to subtract 12x. So I have 3x squared minus 12x plus 1 equals 0. Now, the reason that you can't put the 12 with the 3 or with the 1 is because 12 has a single x on it. 3 has x squared, and 1 doesn't have any x's. So now we're going to use our formula. We have a equals 3, b equals negative 12, c equals 1, and x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Straight replacement. So we're going to replace all of our a's with 3, our b's with negative 12, and our c's with 1. So I have negative b, so b was negative 12, so negative 12, plus or minus the square root of b squared, so negative 12 squared, minus 4 times a, which was 3, and c, which was 1. All over 2 times a, and a was 3. Okay, let's start with that hard part under the radical here. So I've got negative 12 squared minus 4 times 3 times 1. So negative 12 squared, now think about that, that's negative 12 times negative 12. So that's going to make a positive, and that's really important because a lot of people will mess up in their calculator, and the calculator will respond with negative 144. So if you are doing this in your calculator, make sure you wrap up the negative 12 in parentheses before you try to square it. So that makes 144. And then minus 4 times 3 is 12 times 1 is still 12. So 144 minus 12 is 132. So again, we'll do the small math here. Negative 12 and 2 times 3. So I have negative 12 is positive 12. Plus or minus the square root of 132. big divides, 2 times 3 is 6. A lot of people want to cancel that 12 and the 6. You may not do that because there's a plus and minus on top. But even if it was just 1 plus or 1 minus, you still can't cancel 12 with 6 because there's addition on top. So now we're going to try to simplify, and we'll start with 132. Now that's definitely even. So 132 divided by 2 would be 61. No, 66, sorry. And then 66 is definitely 11 and 6, and 6 is definitely 2 and 3. Let me just double check that math. 132 divided by 2, 66. Okay, sorry about that. Oh, no! All right, so we're looking, there's a double 2. I like it. So 2 will come outside, and then there's 11 and 3 left over. So 33, or 11 times 3, will go inside. So I have 12 plus or minus 2 rad 33 over 6. So now my last step is to look at the 3 numbers which are not in the radical. All of those, all 3 of them, are divisible by 2. So I'm going to divide all 3 of them by 2. So I get 12 divided by 2 is 6, plus or minus. 2 divided by 2 is 1. So there's technically a 1 times the square root of 33. But just like a 1 on the bottom, if we're dividing by 1, we don't write divided by 1. And if we're timesing by 1, we don't generally write times 1. So I'm just going to write this as just a plain square root of 33 on the bottom, and then 6 divided by 2 is 3. Now again, somebody wants to cancel the 3 and the 6. Don't do it. The 6 is attached to addition and subtraction. Somebody wants to cancel the 33 and the 3. But again, don't do it, because not only is there addition on top, but the 33 is under the radical. So this is going to be my final answer, or you can write them separately. 6 plus the square root of 33 over 3. 6 minus the square root of 33 over 3. Both of those are the answer. Or you could write it all together like this with the plus minus.